In the field of science, vast puzzles over the subject of what came before the Big Bang have sparked debate and captivated thinkers for centuries. Deep inquiry goes beyond merely examining how we view the universe. It pushes the uttermost limits of human comprehension. Imagine standing at the edge of the known, looking out into the vast unknown, at the brink of time itself, unsure of what previously existed. The universe as we know it was created. The Big Bang occurred, signaling the onset of time, space, and everything familiar to us. But could there have been something before this event? Silence, a state of complete stillness, reigned before the beginning of the cosmic unfolding. And if so, was it really empty? Or was there some form of activity even more remarkable, preceding time itself? As we investigate this further, scientific inquiry takes us on a journey beyond the universe's inception, into ideas that push the boundaries of what we know. Brian Cox, a well-known physicist renowned for uncovering the wonders of the universe, suggests that the unexpected might have existed before the Big Bang. He challenges us to reconsider our notions of reality and existence. In this investigation, we will dissect the hypothesis and the science behind the intriguing mysteries that may help describe what preceded everything we know. We'll look at theories involving quantum shifts, inflationary expansion, parallel universes, and even dark energy. The revelations may astonish you, but they also have the potential to alter how we perceive our place in the cosmos. Prepare to explore a new dimension, where imagination and scientific observation meet. In this space, the unknowable weaves through the darkness, leaving scientists amazed and, at times, unsettled. Let's examine what might have occurred prior to the Big Bang, and why these concepts challenge everything we believe to be true. To comprehend what might have come before the Big Bang, we must first thoroughly examine the nature of the Big Bang itself. According to scientists, the Big Bang was the moment the universe became extremely dense and hot, quickly expanding to initiate the formation of matter, energy, and the fundamental forces. In the night sky, we observe evidence of this. Galaxies with fiery origins moving outward from a common beginning point in history. But why was this so? Was there a phase before this intense expansion? According to inflation theory, there was indeed a time before, and it was far from tranquil or empty. Cosmic inflation proposes that the universe before the Big Bang was cold, sparse, and unstructured, like a vast vacuum. But this vacuum was not completely void. It contained an enormous amount of power that drove the swift expansion of space. Due to the rapidity of inflation, it laid the foundation upon which everything else followed, a phase where space grew at unprecedented speeds. Eventually, this process slowed down, allowing the energy to transform into matter, forces, and particles, bringing about what we consider the Big Bang. But what was that energy, and why did it suddenly activate? What caused the universe to expand so explosively? Experts suggest that this unstoppable inflation could have produced individual cosmic patches, each undergoing its own version of the Big Bang. Imagine an endless sheet stretching out, forming scattered tiny bubbles. Each bubble represents a distinct universe, including our own. This idea, known as the inflationary multiverse, proposes the existence of countless Big Bangs and an infinite number of universes. Ours is just one among many. These staggering possibilities shake the very foundation of cosmology and force us to ask, what else lies beyond? The notion of absolute emptiness before the Big Bang remains highly speculative. Based on current physics, it's not even practically conceivable. Even if we stripped away all energy and matter, true nothingness still wouldn't exist. Our universe is permeated by dark matter, dark energy, quantum fields, and invisible forces, forming an inescapable fabric of somethingness, even in the most seemingly empty scenarios. Despite our hopes of removing all components, new energy could still emerge from this emptiness, as if nothing had changed. This alone confounds researchers and suggests that true emptiness may not be possible. In the context of infinite space, the universe has inherent qualities, constants and physical laws that prevent it from ever being truly vacant. Even in a hypothetical vacuum free of particles and energy, quantum fields and physical constants would persist. This suggests that the nothing we refer to has structure, such as the quantum energy phenomenon known as zero-point energy, which describes the lowest possible energy state of quantum fields. Under these circumstances, particles can still briefly appear and vanish, leaving behind an eerie hum of activity where there should be stillness. This contradicts our conventional conception of a void and implies that something happened before the Big Bang, something we are only beginning to understand. One of the most remarkable concepts in modern cosmology is the possibility of eternal inflation. If inflation caused our universe, it might continue indefinitely, creating new universes without end. Brian Cox discusses an endless multiverse powered by inflation, where universes are constantly forming. Imagine each Big Bang as a spark, igniting a different universe while inflation continues to spawn others in distant realms. This never-ending cycle introduces the concept of a fractal universe, where new universes are born from their own unique Big Bangs, each continuing to exist independently. Rest due to the rapid separation of expanding space. For physicists, this idea is both exciting and disturbing. It implies a multiverse without beginning or end and positions our universe as just a small portion of a vast, growing cosmic network. What if there's only an infinite before or after? A timeless cycle of formation and decay. Our understanding of nothingness changes dramatically when we look through the lens of quantum field theory. This theory suggests that the universe is more than just a collection of matter drifting through space, but a vibrant lattice of energy fields interacting and giving rise to everything we observe. These fields, akin to invisible oceans, ripple with wave-like particles that behave even in their lowest energy state, the vacuum. Particles and fields are dynamic. They can flash into existence, gain energy, and then vanish, leaving behind a whisper of their existence. These virtual particles rethink the idea of a true vacuum. Imagine a universe stripped of matter and radiation. Would that be pure emptiness? According to quantum theory, no. Fields would continue to fluctuate, occasionally producing short-lived particles. This ceaseless activity in the apparent nothingness reveals the universe never reaches absolute zero. Instead, it bubbles with hidden energy that defies emptiness. This insight raises the issue of whether energy fields spawn and produce particles. It's possible that matter formed the universe from this so-called nothing. Dark energy, the enigmatic force accountable for the accelerating expansion of the universe, could be a remnant from before the Big Bang. The fact that dark energy continues to exist could point to an ancient field predating our cosmos. Some theories propose that in a more potent form, dark energy may have triggered inflation and prompted the swift expansion of space. If dark energy persists even when there isn't matter, then it might have formed the circumstances that enabled our universe to come into being. Could it be the hidden hand behind inflation, or even the original spark? As we entertain this idea, dark energy moves from being a passive force to an aspiring architect of existence, concealing information about the multiverse. Another alternative is found in cyclic cosmology. The idea that the universe is caught in an infinite loop of creation, destruction, and rebirth. Here the Big Bang is not a single occurrence, but a stage in an endless sequence of expansion and collapse. Our universe may have risen from the ashes of a previous one, collapsing and re-emerging over and over again. If this theory is accurate, there may never have been a first universe. Instead, existence is cyclical, always changing itself. This model also alters our concept of time, suggesting it may be circular, not linear. A universe born, evolving, dying, and reawakening endlessly would have no true beginning. Ripples in gravitational waves, space created by major events, provide another means of comprehending pre-Big Bang conditions. If gravitational waves were detected, they may bring back memories from before the Big Bang itself. These signals could preserve information about a cosmic state in the past and provide proof that something existed before our universe. Such a discovery would be groundbreaking, possibly validating theories that point to a pre-Big Bang reality. As we pursue these inquiries, we consider concepts that push the boundaries of logic, time, and space. One of the most ambitious is quantum gravity's goal of uniting Einstein's theories and quantum mechanics into one theory. This union could change the way we think about what preceded the Big Bang. According to this idea, space and time may not be smooth, but instead made of tiny units, discrete structures at the Planck scale. These could have produced the space-time fabric we know today. What we perceive as continuous space and time only emerged after quantum fluctuations shaped them from something more primal. This radically different framework implies that before the Big Bang, reality may not have included space or time as we know it. The string landscape, arising from string theory, adds another layer. It suggests our universe is one of many, each defined by different physical constants and laws. Tiny vibrating strings lie beneath each and every particle. The arrangement of these strings results in different universes. This framework allows for infinite possible universes, each beginning with its own massive explosion and independent development, which implies that in the universe we are not the only ones. We are a drop in an ocean of numerous realities. Some theorists propose that our universe might have originated from a black hole in another universe. The singularity at a black hole's center, where density becomes infinite, could theoretically spawn a new universe. The Big Bang may, in fact, be the outcome of such an event. This idea suggests that black holes may serve as cosmic wombs that produce new realities. If true, beyond their event horizons, black holes could be portals to other universes. Finally, the very concept of time may be misleading. If time began with the Big Bang, then wondering what came before is meaningless. There would have been no before without time itself. Some cosmologists propose that time emerged from a primordial state, a chaotic quantum event where past, present, and future were undefined. Others return to cyclic time, where the universe eternally bounces between expansion and collapse. In this vision, the Big Bang is just one cycle among numerous others. No beginning, no end, only a rhythm of cosmic transformation. Based on some theories, one might even imagine a primordial mixture of fields and particles, quarks, leptons, bosons, all churning in a high-energy state before expansion. These building blocks may have existed in a quantum foam, constantly flickering in and out of existence as a result of the uncertainty principle. This soup could provide a bridge to the time before time. In the end, the question of what existed before the Big Bang remains one of the deepest puzzles in modern science. As our understanding of physics, space, and time advances, so too do our theories, each more complicated than the last. While we may never have a definitive answer, the pursuit of this mystery drives humanity forward, fueling our innate desire to look into the unknown.